In this video, we're going to talk about a particular type of methods that we are going to have in our classes. These are constructors. So constructors are very essential to object-oriented programming. A constructor is like I said, a method, but it's a special kind of method. There are a few rules that we are going to cover in the next slide that tell you how to write a constructor. Okay. So for example, here we are assuming that we are inside a class named simple circle. So the definition of the class should be up here. It's not on the slide, okay? But what we focus on, we don't focus on the fields or anything like that, or even the methods in that class. We focus on how we would write actually a constructor for that class. And in this slide, you can see three different constructors. So the first type of constructor that you can have in your class is a constructor that takes no parameters. And that doesn't do anything. The body of the constructor is empty. So the role of a constructor is to initialize the fields of an object when you just create the object. It's called automatically for you pretty much. But the deal is that sometimes you have classes that have no fields, or you simply have fields that are going to be initialized later on by calling different methods of the class. So sometimes you don't have anything to do. So you can write an empty no argument constructor like this one, okay, like the first one on top. And the deal is that, well, that's, I mean, there's really not much to say about this, okay? This constructor is just doing nothing. So most of the time you're going to see people not write any constructor. If your constructor would be that basic, you just omit it. And in a few slides, we're going to discuss that Java, by default, when you write a class, and you don't have a constructor, it's going to add actually such a constructor automatically for you. So that's the most trivial constructor. All right, so the second one, simple circle parentheses, so still no arguments here, okay? The parameter list is empty. So simple circle parentheses, and this time we have some work being done in the body of the constructor, okay? We assign the data field radius that is defined in this class, this simple circle class, we assign it to the value 1. So that's like the archetype of a constructor. It just takes care of initializing all of the fields of your class with default values. That's called a no-arg constructor because it doesn't take any parameter, any argument, okay? And if I add multiple fields here that I wanted to be initialized when the object is first constructed, then I would have several statements here that each assign a default value to one of the fields of that class. So that's the second type of constructor, okay? Still basic stuff. And then just a tiny bit more complicated, okay? Sometimes you want to specify actually what the value for example, the field radius in your simple circle object is at the very moment you create that object. So you create a new object of class simple circle and you want to say this one is going to have a radius of, I don't know, 42. So you need a way to pass this value. So the easiest way is to say my constructor is going to have a parameter. Okay, so I name this parameter just like I would name any parameter for any method. Okay, remember, constructors are really methods. And then when I call the constructor, I pass the value 42, and then this value that is passed as parameter is going to be used to initialize my field radius. Okay, so these are the three types of constructor that we are going to encounter in this module. So I told you that we have some rules about constructor, and you might have noticed already that even though I keep saying, you know, a constructor is just a method, you know, something like that, you might have noticed that, well, they are kind of weird methods. So yes, there are a few things that are weird about constructor. The first thing is you don't have a choice for the name. The name has to be the name of the class, okay? If I go back to the previous slide, you can notice that here, my three different constructors, and I can have multiple constructors defined inside of a class, okay? But the three of them, their name is always simple circle, okay? No choice in the matter. And it has to be exactly the same name, down to the uppercase S and the uppercase C. The convention when you name a class is that you always start the name by an uppercase, Okay, so the first letter of the name of a class has to be an uppercase, and then if the name is made of multiple words, you just concatenate one after the other, but you uppercase the first letter of each of the words that makes up the name of the class. So simple circle, uppercase S, uppercase C, okay? So the constructor has to abide by that exact same rule. Now, another thing that is weird compared to method is that when we write methods, we can specify a return value data type. We can say this method is going to return an int, a double, a float, a string, whatever. And when the method doesn't return anything, we say it returns void. So we have this keyword. So no matter what, whether we plan for our method to return a value or not, we have a keyword that comes before the name of the method. Again, let's go back to the previous slide. You can tell here that I don't have any such thing. Let me clear out a bit my little graffiti here. Okay, if you look at the definition of those three examples of constructor, okay, there is absolutely nothing right here before the name of the constructor. So there is no return data type, okay? And even just to go ahead of ourselves a little bit, there is not even like here a public, modifier. So that we are going to talk about more in a few modules or slides or whatever. But the idea is that for now, just notice that the way that you define the constructor is really streamlined. Okay, so it's mostly the syntax of method, but with the exception that I'm outlining here in this slide. And then, so this is everything above this line is about what is special about when you define constructors. And then when you use constructors, the third bullet item on this slide tells you that, oh, by the way, constructor may be a lot like method, but you don't call them the same way that you call a method. Sure, you have the name of the constructor and parentheses after and arguments, between the parentheses, but you always have to use the new keyword to say that you want to use a constructor. You cannot just call it, well, on an object like we do for method, or call it, without having this new keyword. We're going to see more about that right in the next slide. And then the last point here, but I think I covered that already at length, constructors are a special method that are used only when you create a new object. Java applies them automatically to that object in order to be able to initialize it. Okay, so that's very important. So learn to walk that line between, yes, constructors are kind of methods, but memorize the difference. Make sure you understand them. If you have questions, post on the forums. So let's take a look at how we are going to use those constructors now. Okay, so we're going to start with a very basic example. It's almost too basic, okay, but you're going to see where I'm going with that. So I told you already in the previous slide that whenever you want to create a new object of the class name, you have to use a constructor and you have to use the keyword new. So new, a space, one or more space, then the name of the constructor that just so happen to be the same name as the class, then parentheses, and if it's an OR constructor, then just empty parentheses. If it's a constructor that takes one or more parameters, then you would put a value 1 here, then a value 2, as many values as you have parameter, and make sure, just like when you call any method, that these match the expected data types for those parameters. Okay, so yeah, it's really like a method call, down to the semicolon here, but it's like a method call when you look at it here, but then you have this weird new keyword that has to be in front. Okay, so concrete example of the syntax, you can see them at the bottom half of this slide. Okay, so for example, we could have a statement in a Java program that say new, assuming we have a class named simple circle, new simple circle parentheses, that's it. Or new simple circle 5.0 as argument, and of course semicolon to end the statement every time. So the one thing I warned you about, I said this was going to be weird, is that if Java execute this line of code, and by the way, this is a perfectly valid line of code, it will compile, it will execute, but what happens is that it constructs in memory, okay, a new object of class simple, and I'm going to abbreviate a bit, sorry about that, simple circle with a radius field, and I'm going to abbreviate again, and the first one is going to be initialized, I think the default was 1, okay? And then when we execute, so this is this line, when you execute the second statement, it creates another object of class also simple circle with a radius of, this time we pass the radius as parameter, so we use the constructor that takes an argument and assign it to the field, and there we go, we assign this to the field. The issue with this is that there's something missing here. Those two objects are like floating in memory, but I have no way to access them. So the new keyword only says to Java, create an object somewhere in memory, okay? But then it returns actually an address, a reference to allow you to access a subject. And the issue with those examples here is that while we did the part about creating the object right, we never actually handled that return value of the new statement. So if we wanted to handle it properly, we would do something like simple circle, you know, let's call it S1. So that's a variable, equal, and then I would say equal new, and then I would repeat this here, okay? So now that we create a S1 variable somewhere first, then that would create an object, then that would put the reference of the newly created object in that variable. And now I can start using that object by using the variable S1. So S1 dot, and you know, put name of method or name of fields here to use what's inside, what's available inside that object. So we're going to cover that in more detail. Okay, but right now we have a basic syntax here that allows you to create object on the fly. But of course, since we don't keep in a reference variable a reference to those objects, they are going to be great candidate for being, you know, disposed of immediately by the Java virtual machine, because the Java virtual machine has something called garbage collection. We are going to talk about it at the end of this session, this video. And the garbage collection purpose is when you have like objects that are floating like this in free space, in memory, not being used by any reference variable, well, then probably, you know, the programmer, not probably, certainly the programmer cannot access them. So they are as good as, you know, garbage and need to be disposed of. Okay? So, more about that in a minute. One last remark. You have been using the scanner class, right? We have been doing things like I want to create a scanner, and we didn't discuss much about, you know, creating object and constructor back then. But we just learned that recipe where we could use the Java scanner class. We could create an object like this by using the syntax that we didn't fully explain back then. And then we could do things like, for example, int value equal s dot next int. So we called, there's a t here, sorry about that, next int, we call the method next int on the object reference to by the variable s, which is an object of class scanner, and we say pretty much give me the next int that the user is typing, okay? So we used all that stuff like that. But this little notation here that I introduced means that instead of creating a scanner, assigning it to a variable s, and then using that scanner through the variable s, if you are going to use it only one time, if you're using it multiple times, then by all means, store the reference in s, keep using it. But if it's a one-shot thing and you're never going to use s again, you could even do something like that. Int value, okay, equals, and then new scanner system dot in, okay, and dot, so I don't have room here, but it should be on the same line, okay, next int. So what's going on here? Well, I kind of collapse everything in one line, right? I define my value variable, and then I say, okay, I need now to read an int from the user. So reading an int from the user means calling the next int method on an object of class scanner. And this is how I get my object of class scanner. I get it on the fly by calling new scanner system in. So this returns me a value, a reference to the object of class scanner, and then I do dot next int. I apply dot next int, you know, to that value, whatever it is, okay? So I take the reference, I use the reference to call next int on that object, and then I'm done. I never stored the reference, I really just don't care about it, okay? So that's pretty much what I wanted to illustrate with this weird notation. Yes, it is a weird notation, but I wanted to use that example here on the top right of the slide to show you that even though it's counterintuitive when you just are beginning programming in Java, it has some application and some use somewhere. So it's not a useless notation. So now let's talk a little bit about default constructors. So I already mentioned that, okay, but we're going to go formally over it. So if you do not define any, and I should have added here the word any, if you do not define any constructor in your class, if you don't write the code for any constructor at all, okay, then Java is going to step in, because you always need a constructor in a class. Every time you create an object, Java is going to allocate the memory for the object, and then it's going to apply a constructor corresponding to your class, okay? So if you didn't write any constructor, Java is going to step in and say, well, I'm going to write the constructor for you. So it's going to write the simplest example of constructors, the first example that we considered 2 slides ago, the no-arg constructor with an empty body. So it doesn't do anything, but it's just a standing, okay? This is so as there is never a situation where a class doesn't have a constructor for Java to call. Even if the constructor does nothing, Java needs to be able to call it, get it over with, okay? So this is called the default constructor. Name is kind of appropriate, okay? It's provided automatically and only if you didn't write any constructor. So if you write a no-arg constructor with an empty body, well, then you did the job of Java. If you write a no-arg constructor with a body, then that should not be replaced by something that does nothing. You wrote a no-arg constructor, it has to be used, and what has to be done is in the body of this constructor. And now if you write even a single constructor in your class, and this is a constructor that takes, I don't know, 42 parameters, well, that's it. That means that the only constructor you wanted in your class is the one with that many parameters, and Java will not dare to step in and add a no-arg constructor to that. It will assume that you know what you are doing, okay? So let's talk a little bit about declaring object reference variable, which we kind of a little illustrated, you know, in 2 slides ago, but we're going to go back again in detail. So I told you 2 slides ago, well, the problem is we don't have a reference. So here's the syntax to say, I want a reference variable. So when I talk about those variables that are meant to reference, you know, an object of a certain class, I would say, for example, we define here the variable myCircle, which is a reference variable meant to refer to an object of class simple circle. And that phrase, you're going to hear me say it a lot, and I try to stick to it as much as possible. A lot of people say myCircle is a variable that's an object of class myCircle. That's not actually technically correct, okay? That would mean that myCircle is a variable that is an object of class simple circle and has its radius inside of it. And by now, from the diagram that I drew on the slide, you should know that this is not actually how things work in reality, okay? This is not what happens when you issue one declaration like that. So what actually happens is that you have, if you write this line here, okay, you have myCircle, which is just a tiny variable, and it's meant to contain a reference value. So let's represent a reference with a Greek letter, alpha, and that reference value refers to, did something fancy here with a pen, refers to an object somewhere in memory, okay, with its own radius field. But when you just declare the variable like here on this line, you didn't create the object yet, right? So your variable here is actually a reference variable that has an uninitialized reference in it. So don't even know what that means, okay? It could point to anywhere, anything. That's not clean, actually. That's not good, okay? So when you want to declare a reference variable and you don't want to create an object on the fly, which we are going to again review in the next slide, what you would do is you would remove that semicolon here, do equal null semicolon, Okay, we'll talk more about that in a few slides as well. But that means that the value here of the reference would be null, which means it's clear that my circle does not reference yet to any object whatsoever. Okay, but for now, the most basic way of declaring a reference variable is like that. Just understand that this does not create actually an object. What creates an object is when you do things like this. So you could even have, in this example, we have the typical line, you know, where you do everything in one shot. You define my circle, okay? So that's what's happening here. I define the variable my circle. So that's the first step. So my circle comes into existence in memory, but it's just a reference variable. Then the second step is you actually apply the new operator and call the constructor of the class, and you create an object of that class in memory. So the no-arg constructor for simple circle assigns value 1. So that is the object here, right here, okay? This is the object that exists in memory. And then you assign the return value of this operation, which is the reference. You assign that reference to the variable myCircle, and now you have this blue arrow here, okay, that allows myCircle to reference the object of class simple circle. So that's actually the full that is a full everything done in one step, okay, in one line of code. You could also do something like first simple circle my circle. So what we did in the previous slide, so this would define actually this variable, and then you could just say, well, now that I have a variable my circle, I can say my circle is assigned, you know, create the object, then assign here the reference to that object to my circle, and that would be the same. Those two lines are exactly the same than what was originally on this slide. Okay, it's just a matter of, I guess, programming style. If you have to create your object immediately when you declare your reference variable, then you would do it as originally shown on the slide. But sometimes you just have a bunch of reference variables that point to nothing, and then later on you assign new objects to them, okay? So that the two are acceptable, the two are syntactically correct and make sense. It depends on what you want to do. So let's talk now about accessing object members. Okay, so we have done that already in the past. The syntax is you use that variable, okay? So for example, my circle, okay, that variable, that reference variable that refers to an object of class simple circle, okay, which is on radius. So you use that variable name, you use a dot notation. So every time you have a reference variable followed by a dot, that means I want to use that reference variable to find an object in memory. So this guy here, okay? And then I want to do something on that object. So if you write the name of a data field, that means you want to access that data field. So you could write something like my circle dot radius equals, I don't know, 42. So you assign a value to that radius here inside that object. Or you could write something like system.out.println and then my circle dot radius. Okay, so in that example, what you are saying is, in the first example, we write the value 42 inside that radius field, inside that object referenced to by the reference variable myCircle. In this example, we look at the radius value inside the object referred to by the reference variable myCircle. We find the value 42, and we pass that as an argument to system.out.println so that it can display the value of that field inside that object. Okay, so that's accessing object members that are fields. And then there's another type of object member, okay, which is a method. So for example, in the simple circle class, we have a method named getArea, okay? So every object of this class has that method getArea that computes the area of the circle based on the current values of the radius field, okay? So same thing, you say, let's start with my circle, let's start always with a reference variable. That gives me the reference where I can find the object. So let's take value alpha, okay, for reference. and then you use the dot notation. So you say, I'm going to use that reference to find an object, and then what do you do on that object? And in this case, you say, I want to apply the getArea method that's defined in the class. I want to apply it to this object. So that means that whenever the getArea method is going to reference to fields that are defined in that class, these are the fields that are going to be used, the fields that are defined inside that object. Okay? So that's something that we're going to do all the time. That's the whole point, okay? You define a class, so you say every object of that class is going to have those fields and those method a variable. Then you create an object, and then you start messing around with the specific fields of a specific object and calling those methods defined in the class on that object. Okay, that's the whole point of object-oriented programming. You write code that can be used for many different objects that are pretty much of the same type. Okay, so a bunch of simple circles, for example. Okay, so that's it for accessing object method. One quick word of caution about this. So next slide. We have been using a syntax that should look weird to you right now in the past. Okay, we have been using a syntax where in COP2512 where we would have the name math with uppercase M. So that suggests this is the name of a class, right? Uppercase letter at the beginning of the name. Then we used the dot notation after the name of a class. That's weird. I just told you that we were using the dot notation after the name of a reference variable, okay? So yes, it's possible to use also the dot notation after the name of the class, but it means something completely different. I mean, significantly different. For you to be able to understand that, we need to cover the section on static variable, constant, and methods in the textbook. It's going to come in a few slides, okay? But for now, what I want to point out is that, yes, instead of using a reference variable followed by a dot, followed by a method name and the parenthesis and argument, in the past, you will find that we used this kind of stuff. A class name followed by a dot, followed by a method name, the parenthesis argument. So it sounds like we are trying to call a method on the class itself instead of calling it on an object. So the natural question you might have is, wait a minute, so does that mean that I can do something like simple circle dot get area? And the answer is no. The answer is no, because every time we use something like that, okay, and math is defined for us, so we didn't have to write the class math. It's given to us by the JDK. But every time you have a class that allows you to call methods directly on the class, those methods have to be defined using the keyword static. I write it uppercase so that it's readable, but it's all lowercase, okay? If you use the keyword static to define a method, and we're going to get into that in more details, okay? Just be patient. But if you use the keyword static, then you can call the method on the class itself. If you do not use the keyword static, which we didn't use in the example I went over in the last few slides, then you cannot call something like getArea on the class itself. You have to call it on an instance of the class, on an object that has been created and that belongs to that class. Does that make sense? All right. So, last thing that is also a kind of warning also on its own, okay? So far we have talked about a lot of class example where the fields are things like int, boolean, char, double, float. So pretty much any how to say, primitive data type, okay? But you can also have a field that is going to have a data type which is itself a reference to a class, okay? So in this case, let's say that I do student S1 equal new student. Let's assume that I have a no arg constructor, okay? So what I do is I have a variable S1, and now it contains a reference to an object of class student. And this object of class student has multiple fields in it that are defined here, okay? And then one of those fields, the name, okay, so I'm going to write name here. Well, it's also a reference variable, so I could write something like s1.name, so that allows me to access the field name inside the object reference to by reference variable S1. And I could say, hey, I want to create a new string, okay? And I'm going to just even leave it an empty string for the sake of this example, okay? But that means that now I assign to the name field the address of a new object in memory of class string that has its own, you know, fields and method and stuff like that. So you see how we can end up constructing diagrams here that represent what's happening in memory. Those two lines of code, they make quite a lot of things happen in memory. And it's really important that given even a few lines of code or many lines of code, you are able to generate those kind of diagrams accurately. If you do not have those diagrams on a piece of draft paper nearby or in your head, you know, eventually you will internalize that stuff, but start with paper. If you are not capable to draw those memory diagrams correctly, then that means you do not understand what's happening when you create object, what object is where, which one is still accessible, which one has no reference to it, blah, blah, blah. So you're not able to trace your code, right? So that brings us to the first difference between COP 2513 and 2512, right? In 2512, we learned to trace code with if statement, loops, method calls, and stuff like that. Well, you still need all that stuff, but now we are going to also learn to trace code that has objects being constructed, and we are going to learn to make those diagrams, and we're going to learn to follow the arrows, you know, when we are writing statements such as s1.name equal new string. So we create a new object of class string, but then where does the reference go? Well, it goes here, you know, inside that field, inside that other object reference to by s1. Okay, so that's going to be one of the challenge of getting used to object-oriented programming, is the fact that, yeah, we can have some diagrams like that can become quite involved, and you have absolutely to be able to interpret the code to draw those diagrams, pretty much. Okay, that's completely mandatory if you want to understand object-oriented programming. All right, so other thing in the side. What if you have a bunch of fields like that in a class and you don't even bother to write a constructor? So Java is going to give you the equivalent of a no-arg constructor. So something that would look like student, you know, blah, blah, and then empty body here, does nothing. So if you are in that situation, what's going to be the default value for all of those fields? So when you talk about fields in a class, okay, they do receive automatically default value. Any field that is actually a reference to another class, like name, is going to get the value null. Any int is going to get the value 0. Float and doubles are going to get the value 0.0, which is 0 in floating point number. Booleans get false by default, and characters get this weird string here that represent a Unicode code. Okay, so it means that this is a default Unicode character. It represents nothing, null character. So what we have here is we have a class that really is a minimalistic class, just has a bunch of fields in it, and Java takes care of initializing these fields even in the absence of explicit initialization by a constructor. Now, I mentioned that if you have a reference field, it gets a special literal value called null, uppercase N-U-L-L, okay? So this is very useful. It's used whenever you have like a reference variable. If you put null to it, inside of it, sorry, so S1 equal null, what you are saying is, I don't refer to an object yet. And later, you can assign a reference that points to a new object that you created with a new operator. That's great. But right now, it's a clean way to say, your variable is a reference variable, but it refers to no object. And if you ever try to use, you know, s1.getArea because you think that, for example, you have, for example, simple circle S1, so the data type of S1 is a reference variable meant to refer an object of class simple circle. You assign null to it, so because it's supposed to refer an object of class simple circle, sorry, you might be tempted at some point to do s1.getArea, but since you have null here, Java is going to immediately understand that something is wrong, and it's going to crash your program at runtime. It's called a null pointer exception. Okay, null reference exception. The idea is that you think that you have an object to talk to, but you don't. Now, if you were doing things, you know, differently, and you had here steps for creating an object of class simple circle, okay. Now S1 would not contain null, it would contain actually a valid reference, okay. Again, let's call it alpha to give you a name to that value. It would contain a valid reference to an object of class simple circle with its own radius field, okay. And now you could use that. Okay, so that's null is a special value that allows you to have a placeholder that say, well, that reference variable doesn't point to anything, doesn't reference to anything. Let's talk now about default value for local variables. And it's an important thing to understand because this is a source of a lot of bugs, okay? So first, sorry, I went ahead of myself. First, the default value for a data field. Okay, we kind of covered that already, like 99%. The default value for a data field are the values that were listed before. Okay, so if I was creating a new object of class student and then displaying the field in that object, I would get here for the name, I would get a null string, I would get 0 here, I would get false here, and I would get what was student.gender, I forgot. Student.gender was a character, so I would get the Unicode character blank, you know, here. So that's for data field. But now, the one that I wanted to insist on is what happened with local variables. So there is a totally different rule. That's what you need to remember. Java is okay with assigning default value on your behalf to class fields. But when you are inside a method, like for example here I am inside the method main, and you define local variables, okay, like we did in the previous class, when we didn't really mess around with classes a lot, okay? So if you do that, then this is going to be a compilation error because you are trying to use the values in X and Y, but you never initialize X and Y. So initializing means something like int X equal 42. You assign a value when you declare the variable, but you also never assign the variable to X. So for example, you could have int X declaration, a bunch of line of code, and then X equal 42, and then try to display X. That would be okay, because even though you never initialize the variable, so you know, it had no default value, it had random junk in it, so it was unreliable. Later on, you assign a value to that variable, and now you are capable to use that value, okay? No problem there. But be careful about this, because this is a common source of confusion. Another common source of confusion is the difference between variables of primitive data type and object type, okay? So variable of object type, that means reference variable that are meant to contain a reference to an object of a certain class, okay? That's how we are going to phrase it in this class. So if you look at this example here, we have a declaration of an int I that is initialized to 1. Int is a primitive data type, so the primitive data type in Java are int, float, double. You'll find a list in your textbook, okay? What else? Boolean. They all start with a lowercase, okay? So these are primitive data types. So they are handled a certain way by Java. Like for example, here you define I, variable I, you assign 1 to I, okay, perfect. Then let's say that you have a circle, simple circle C, and then you do new simple circle. I'm adding here to the example because the example on the slide is kind of incomplete, so I don't like that. But so now you have a variable C that is a variable of type reference. You created an object in memory of class simple circle, and then you put the reference right here inside of C. So now you have this beautiful arrow that allows you to reach that object that you allocated. Okay, so that's okay. We already covered that. That's nothing new, or it should not be anything new. Okay, but now the difference between reference and primitive data type shows really when you do things like that. For example, if you have two variable I and j, okay, so you had int I equal 1, int j equal apparently 2 from this example, okay? So you have in memory two variable I and j equal to 1 and 2 respectively. If you write the assignment, if you execute the assignment I equal j, the value that is in j is copied into I. But I and j are two separate variables. They are still two completely independent variables, right? Okay, now what happens if you have simple circle C1, C2. And then C1 equal new simple circle. There we go. And C2 equal new simple circle. So what's happening now is I have two reference variables C1 and C2, and they each received a different reference corresponding to a different object of class simple circle that has been created in memory. If I execute the assignment C1 equals C2, now it's different. I take the value, so let's call this reference alpha, let's call this reference beta. I took the value in C2, beta, and I assigned it to C1. Okay, so that's what happened. So if you look at this and you compare it to the previous example, it looks like we treat the values inside of reference variable just like we treat primitive data type. And you are correct in thinking so. Take the time to unwind this, okay, because that's a very big source of confusion. So yes, C1 and C2 contains values, just like I and j. And when you assign C2 to C1, you take the value in C2, you assign it to C1, just like you did with I and j. The difference is that those values represent something different. An int value just represents a number. A reference value is itself a form of complicated number, maybe, but it represents an object located somewhere in memory. So right now, both in C1 and in C2, you have a reference to the same object in memory. So if you were to use C1.radius for anything, like displaying it or changing it, it would refer to this field in this object. But if you use C2.radius, it refers to the same field in the same object, okay? Those two arrows that are outlined in red are showing you that the two variables refer to the same object. So again, it goes back to tracing. It's really fundamental that you understand this. You have to be able to detangle those kind of situations. You have to be able to understand what code does before to be able to write it, okay? So if I write some complicated code that has C1, C2, C3, I create maybe a total of 5 objects, so I even create more objects than there are variables, and then I just, assign one to the other, blah, blah, blah. You have to be able to follow step by step, even a complicated, example like that, just by knowing, what happened with each elementary step. So when you create a new, this is what you do on your diagram. When you assign the value to a variable, this is what you do in your diagram. If you know how to do those simple operations that we covered in the slides, then all you have to do when you have a long sequence of them is take it one step at a time. Don't go too fast. Don't get in over yourself, okay? Just follow step by step. Each of the steps is simple. What's complicated is the temptation to read ahead of what you are executing right now and just assume things instead of actually, applying the rules that you learned one by one rigorously. So always the problem with tracing, right? Let's talk about garbage collection. So I already mentioned it briefly, okay? So let's go back to the previous slide because it's a great example of where a garbage collection would kick in. Let me clear a little my graffitis here. This is not relevant. This, we're not going to talk about it. Let's talk about this diagram here on the bottom right of the slide, okay? So we have two variables, C1, C2. These are reference variables meant to hold a reference to an object of class simple circle. And then C1 and C2 refer to the same object. C1 used to refer to a different object, that one. So what happened to this guy here, this object, okay? Now that C1 doesn't refer to it anymore, this arrow doesn't exist, there are no arrows pointing to that object anymore. That means that nowhere in my code I have a reference to that object. So this is a prime candidate for Java to get rid of. It's an object that has no reference to it in my code. So there is no possible way I could write, something that holds that reference, dot, and then a name of a method or a name of a field to use anything in that object. That's how Java knows that this object is garbage. Okay, so once Java identifies an object as garbage in memory, it's going to eventually, and the operational keyword is eventually, it's going to automatically dispose of it, free the memory that is currently occupied by that object. But you don't necessarily know when exactly, except if you are a Java virtual machine internals guru, okay? But you don't know exactly when this is going to happen. It's totally up to Java. When Java feels that there is a need for more memory, or when it feels that it has been a long time since it has actually checked last, if something needed to be getting rid of, then it's going to kick in what is called the garbage collector, and that garbage collector is a part of the Java virtual machine that's going to inspect memory, find out those objects that are no longer usable by your code, and dispose of them properly. But the good news is that means that in order for you to use objects in Java, you have only to worry about when you need to create them. So you need to worry about calling new and calling a constructor and allocating memory for the object and initializing it. But you never have to worry about disposing of objects, okay? This is really important. Now, let's say that you have a reference to an object, and you know that you don't need that object anymore. It's considered good practice to say that, for example, if you have a variable S1 that is referring to an object of class student, and you know that you don't need that object of class student anymore, it's common practice to do something like S1 equal null. That's your way of saying, well, I used to access that object here, right here, via S1, with S1, but now I don't need that anymore, so I'm going to ditch that reference here. As soon as you assign null, you lose the reference that was in S1, and so you lose this row. If other variables were referencing that object, it will be kept in memory. That means that other parts of your code need to still use that object. But if nobody is referencing that object after you do that, then eventually the garbage collector in the JVM will get rid of that object. But again, it will do so on its own schedule, its own will, pretty much.